Hi everyone. In this video, we are going to talk about the importance of supply bypass capacitor in analog circuits. You might have seen in a lot of circuits, this kind of supply bypass capacitors are used, but we never understand the proper reasoning behind that, why it is used in the circuit. So we will try to understand that thing in this video in detail. So let's say we are taking two op-amps which are connected back to back. So those two op-amps are shown here. Let's call this as A1 and let's call this as A2. Even A2 op-amps are connected in series and input is given as Vin, which is applying at the op-amp's input, and Vout is the output of op-amp. Now, in order to make this op-amp operate, we need to have a proper supply and ground connection which should be given to both the op-amps. So ideally, what we will do, we will use one supply and we will connect this supply directly to this op-amp. Similarly, ground will also be connected to both the op-amps. This is how ideally we try to connect, but in practical we understand simple metal wire will offer resistance and inductance both in nature. So when we connect simple metal wire between battery and op-amp, resistance and inductance comes into the picture, and that's what is shown here in the structure. You can see we have shown RVDD and LVDD as the supply inductance and supply resistance, and similarly RVSS and LVSS represents the resistance and inductance which is offered from ground connection. Similarly, between op-amp 1 and op-amp 2, since we are trying to share the supply and ground, so since it will also be connected through a metal wire, so this R1 L1 will represent the inductance and resistance between these two op-amp supply, and R2 and L2 will represent the inductance and capacitance between the grounds which is being shared from one op-amp to second op-amp. So now you can understand, ideally we wanted to have the same supply and same ground to both the op-amps, but because of this practical nature of metals, it offers resistance and inductance. Both the op-amps will not face the same supply and same ground. Both will face different supply and different ground. Now, what it will do if any inductance and resistance are getting introduced between the supply, so how it will impact the proper supply. So ideally, if we have applied a supply, let's say VDD, we wanted at the op-amps to have the similar supply like VDD. And similarly, if we have applied ground VSS, that is, let's say, equal to 0, so we wanted to have the same value at both the op-amps. But because of this R and L introduction, we won't be getting the same supply and ground now. If we talk about the impedance in the supply, so overall, between supply and first op-amp, we will see this much impedance. The value of this impedance would be equal to Rs plus Ls. In frequency domain, if I'm talking about the total impedance, that would be Rs plus Ls. And similarly, here between ground and first op-amp also, we will see Rs plus Ls. The values of Rs, Ls will depend at the length of this metal wire. If the connection length is less, let's say between VDD and op-amp, the metal wire which is drawn is having a very small length, so R and L value will be less. If the metal which is being drawn between VDD and op-amp is of very high length, so R and L value would be high. Because of this impedance, we will see some drop in the supply voltage and some drop or raise in the ground voltage also. So if I talk about the drop because of this resistance, that would be equal to VDD minus, let's say, current which is flowing because of this supply is I. So I into, so this is the drop which this resistance will. And if we talk about the drop because of this inductance, so inductance drop can be represented by L di by dt, right? If L value is higher, so more drop will be there. Let's say this Vin is very high frequency signal which is having this kind of nature. So during transitions, the amount of current which will be sourced or sink in this circuit will be very high. So if I try to draw the current profile which is going inside this op-amp, that will have something this kind of nature. So during edges, the current will have a sharp rise and sharp fall, peaks will be there, and during DC condition it might not be having significant current. Now if this kind of current is being sourced, being fed as an input to inductance, so because of this di by dt factor, the amount of drop that will occur across VDD will be very high. Because of this differentiation, the edges will become more sharper and we will see more drop across this op amp. Also, if I try to draw a graph between Z and frequency, so Z means this impedance we are considering, we are trying to draw a graph of this impedance, how it will vary with respect to frequency. So overall impedance is Rs plus Ls. So at the DC frequency, a very low frequency, the impedance offered will be only because of R, right? It will be less. And as the frequency will continue to increase, the offered impedance value will also increase. So something this kind of impedance profile you will see. So at higher frequency, it will be high, and at the lower frequency, it will have some constant impedance. So as you will increase the frequency applied to this op amp, the spikes of current will be more, di by dt factor will be more, impedance will be also high at high frequency. So because of that, the drop that will occur at supply will be very high, because impedance is also high, current profile will also be high, so you will see more drop across this supply. So you will get very weird supply or a lot of drop across the supply at op amps, and because of that your op amp might not function as intended, right? So that's the issue, and we need to mitigate that issue. And this is not only across supply, even at ground also similar kind of nature or similar kind of waveform you will observe. So the question comes in our mind, how we can mitigate this impact, right? Because ideally we want to have as ideal supply as what we have applied as an input, so that our op amps or any circuit can work as intended. So the one thing which we can see here from this two waveform is that if we are in DC mode of operation, we are not getting impacted because LDI factor is not coming into picture. So whatever supply we are applying, almost that we are getting at this op amp's input. The major concern which we are facing at high frequency, because their impedance value is also getting very high, and this I waveform at the edges is becoming more sharper. So because of that, we are seeing very huge drop across this op amp. So somehow if we can filter the high frequency component and only allow to pass the DC component to this op amp, our op amp will work as intended, right? So that is why we use this capacitor here. Now capacitor, what it will do? If we talk about the Laplace property of this capacitor, so it can be represented by 1 upon Sc, that is equal to 1 upon omega c. So if frequency is very high towards the infinity, let's say, so Xc will become 0, and if frequency is 0, Xc will become infinite. That means at DC frequency, at a very low frequency, this capacitor will oppose the current flow from this path. It will offer very high impedance, so all the current will flow from VDD to this op amp. And that's what we want. At low frequency, we are seeing the impedance is very less. At low frequency, this role of inductance is negligible. So whatever supply we are applying, the same will be fed as an input to both the op amps. And that's what we want. But as soon as we are moving towards the high frequency, impedance is becoming very high. Current spikes are coming into picture. So we want to filter this part. We want, as soon as we are moving towards the high frequency, all the current should flow through this path, and any such current should not go in op amp which can disrupt the operation of our op amp. So at high frequency, this impedance of capacitor will be very less. It will be kind of a short circuit. So all the current components will go through this path. At high frequency, all the high frequency current component will go through this capacitor path, and our intended circuit will be safe. So that is why we use this supply capacitor in op amp. It's a kind of a power supply rejection ratio method. By introducing a very high value of capacitance, we can allow to filter the high frequency component so that our op amp can work as intended, and at lower frequency it will oppose to the current flow inside this capacitor. So all the current from supply will go into the op amp, and our op amp will work fine. Even if I try to bring the impedance part in this in this graph also, which is drawn between impedance and frequency. So you can see at lower frequency, impedance is very high because of this capacitor, and at high frequency, inductance is almost zero. So this kind of waveform something you will get because of inductance. At lowest frequency you will get highest impedance, and at highest frequency you will get lowest impedance. So overall, if you see, because of both of this structure, if I talk about this structure only, RLC, so combined, both will cancel out each other, and throughout the range of frequency we will get something, this kind of impedance across the range of frequency. That's what we wanted, to have a less impedance between supply and op-amp's input, so that whole supply which is applied there can directly be given to the op-amp, and we don't get any disturbed output. So this is the reason why we use supply bypass capacitor. It is called a supply bypass capacitor because it bypasses all the high frequency component and allows to flow only the low frequency component in the op-amp. So that's the reason we use supply bypass capacitor, and usually the value of the supply bypass capacitor is kept very high. The more the value of this capacitor would be, the lesser would be its impedance, and the more lower impedance we will get, because it is coming in parallel with RL. So in parallel, whatever is minimum, that will be dominant. So we will get minimum impedance here. That's what it desired. So that's why we use supply bypass capacitor in so many analog circuits. Many people use this, but they don't know about the exact reason behind using that. So through this video, we try to explain why we use supply bypass capacitor, and it is one of the best way to oppose PSRR in op-amp. There are other ways also which we will study later on this channel, but this is one of the best way to use that. Thank you so much for watching this video. If you found this video useful, please share with your friends, and if you haven't subscribed this channel, please do subscribe.